Hello everybody! This video is a part of a tutorial showing how GIS can be used in conflict research. If you are interested in the full tutorial, please have a look at the video description. You can find a link to our worksheet there, as well as a Google Drive folder containing all the important layers. This video covers the final step of our analysis. First, we will show you how to prepare your data, including rasterizing vector data, reclassifying it, and filling in no data cells. After that, we will show you how to perform an opportunity and willingness analysis. To give you a little bit of background information, opportunity and willingness is a concept suggested by Harvey Starr. According to him, opportunities are the possibilities that are available within any environment to take part in a conflict. Willingness is the choice and process of choice that is related to the selection of some behavior option from a range of alternatives. In other words, the reason why an individual might engage in a conflict. Our goal is to map 10 factors contributing to conflicts in the Yonglai region in South Sudan. 5 of them fall into the category of opportunity, and 5 of them are considered willingness factors. If we will calculate an index for both opportunity and willingness and combine them later, we will be able to identify conflict hotspots. For more information, please check out our worksheet. We will start by calculating the opportunity index. To do so, we need to insert the county capital layer, the streets and the roads layer, the livestock layer, and the EPR borders layer that we prepared in previous steps of the tutorial. If you haven't done that yet, please pause the video and follow the worksheet or download the layers from our Google Drive folder. As you can see, some layers are vector layers and some layers are raster layers. But if we want to bring them together, we need to rasterize our vector layers. If you want to rasterize a vector layer, it is handy to have a reference raster layer. In our case, we will use the livestock layer. To find out more about the pixel size of this layer, we can go and open up Properties. Under Information, we can see Information from Provider, and there we can find the width and the height of a pixel. Write them down as we will need them later. We will use the tool Rasterize to convert our capital layer into a raster layer. We will go on Raster up here, go down to Conversion, and choose Rasterize. We will choose the vector layer we want to convert as an input layer. Next, we need to indicate the field to use for burn-in value. In this case, for capitals, it's ID. Under Output Raster Size Units, we choose Pixel. Next, we will need to insert the pixel size that we wrote down earlier. That way, all our rasters will have the same pixel size and fit together nicely. The last thing we need to fill in is Output Extend. We click on the arrow on the right, select Calculate from Layer, and then choose our livestock layer. The rest can be left in the default settings. Now we just click Run. You can see that the round vector features have been replaced by pixels. We now want the pixels to all have the same value, 1. To achieve that, we go over to Raster, Raster Calculator, and type in the following equation. We need to select a file to save our new rasterized layer to. And then we click OK. Now we will use the Identifying Feature tool to see our values. You can see that where the pixels are, the value is 1, but when we click in the other region of Yonglai, you can see that there is no data. This might be a problem later on. Therefore, we will need to change these values to 0. We click on the toolbox and search for Fill No Data Cells. As an input layer, we choose the raster layer we want to change, and fill value should be set to 0. You should find a place to save the file and click Run. Now you can see we have a new layer. We use the Identify Feature tool again and see that our pixels have the value 1 and everything else has the value 0. We have to repeat the same process for all the vector layers. You can either do that now and pause the video, or you download them pre-made from our Google Drive folder. Once we have inserted them all into our QGIS, we can start calculating our opportunity index. To do that, we go up to Raster, Raster Calculator, and add up all the layers. Then we will just have to select a file that we want to save our results in. And we can click OK. That will generate a new raster layer for us. This layer can have values ranging from 0 to 5. 0 means that not a single opportunity factor was present at this pixel. 2, for example, could mean that both a road and a border, but none of the other factors were present. 5 would mean that all the factors were present at this location. This is not the case for any of our pixels, but it could happen when you create the willingness layer. You will have to repeat the exact same process for willingness. If you don't want to do it by yourself, you can also download the willingness index layer from our Google Drive folder and continue. According to research on opportunity and willingness, the areas with medium opportunity and medium willingness are most likely to experience conflict. Medium equals the index values 2 and 3 in our analysis. Therefore, we need to extract the pixels with these values. To do that, we will first go on the toolbox icon again. We will search for Reclassify by Table, and that will open a new window for us. We will start with Opportunity, therefore we select the Opportunity Index layer, and then go to Reclassification Table and click on the 3 dots on the right. Next, we will add 3 rows. In the first 2 columns, we indicate the group of values we would like to reclassify from minimum to maximum. And in the third column, we enter our desired new value. Make sure it looks like this, and then click OK. After that, you can click Run. This is our new layer, and we will edit it in the raster calculator once again. Type in the equation, and then find a file to save your results in. Click OK. And there you have it. The first layer is prepared for our final step. As always, we need to repeat the same process for our willingness layer. We already prepared that, but if you need time to edit your willingness layer, just pause the video. Now for our final step. We have 2 layers, both of them with the values 0 and 1. We will now use the raster calculator again to add up those layers. We will save our final results. And there we have our final layer. The layer has the values 0, 1 and 2. 0 means that there was no medium index. 1 means that either opportunity or willingness was medium at this location. And 2 means that both opportunity and willingness were medium, and therefore this area is a conflict hotspot, according to our analysis. To visualize our results, we will adjust the colors under Properties and Symbology. Like that, and this is our final results. The red areas indicate our hotspots. To see how accurate our analysis was, we will compare our conflict hotspots with actual conflict data. We downloaded conflict data for South Sudan from UCDP. You can find a link to their website in our worksheet. We filtered the data to fit our area of interest and the period of our project. For a tutorial on how to do that, please look at our worksheet. As you can see, quite a few points lay within our conflict hotspots. To quantify that, we will use the sample raster value tool. You can find it in the toolbox. As an input layer, we choose our conflict data, and as the raster layer, we choose our hotspot layer. For a better overview, we will name the new column Sample Values, and then you can either save it or just click Run. This is going to create a new point layer. There you can see it, the yellow points. We're going to look at the attribute table now. On the very right side, there is a new column called Sample Values. As you can see, in total, there are 196 conflicts in the Yonglai region from 2011 till 2020. And now we're going to filter them and see how many conflicts occurred in our hotspots, or in other words, how many of them have the sample value 2. The conflict events with the sample value 2 are now selected, and we will isolate them by exporting the selected features. We will save the new layer. And now we can check out its attribute table. At the very bottom, you can see that only 109 of the conflicts are left. That means 109 out of 196 conflicts are within our hotspots. That is around 55% of them, which we consider a fairly good amount. If you would like to recreate every step of the analysis, or if you want to learn more about the opportunity and willingness concept, please check out our worksheet. If you have any problems or questions, feel free to ask us in the comments. We highly encourage you to test out this concept in other study areas. If you were successful, tell us about it in the comment section. There's not a lot of GIS tutorials for peace and conflict research out there, so we hope this tutorial was helpful to anyone interested. If so, please give us a thumbs up. This video is part of a project for the seminar B12 GIS for Peace and Conflict Research at the Department of Geography of the University of Bonn. We hope you enjoyed the video. Have a nice day.